Welcome to this introductory module on large-scale language models. Throughout this course, we will not only learn about what they are, but we will also delve into the features and applications. In recent months, there has been a lot of discussion about these models, particularly with the emergence of ChatGPT, which has raised questions about whether they present a great opportunity or significant threat. While it is true that these language models are highly useful tools for automating a wide range of tasks and generating content, they also carry certain risks that we will thoroughly analyze during the course, along with their limitations. On the topic of benefits, we have already witnessed how they are revolutionizing various aspects of users' lives. For instance, IBM recently announced that it has ceased hiring staff for certain positions that can be filled by these language models or ChatGPT. Additionally, it is expected that these advancements will impact a significant number of creative jobs. Even the most traditional sectors are adopting these technologies. Mercedes and Microsoft, for example, have begun implementing ChatGPT in vehicles, with the expectation that this implementation will be successful in the coming months. Consequently, despite the risks involved, the applications of these models are expanding to numerous industries. So, why should we pay attention to these technologies now? Large-scale language models are not new. They have existed for years, including models like BERT. However, what has changed is the quality of these models. In the past, tuning and adapting language models for specific use cases required extensive manual work. For example, if you wanted to analyze product reviews to determine the sentiment, positive or negative, you had to make manual adjustments. Today, thanks to advances in constructing and fine-tuning these models, it is possible to provide these instructions in natural language and have them perform useful tasks with minimal human intervention. This is attributed to two primary factors. Firstly, the accuracy and effectiveness of the models have reached a tipping point, enabling a wide range of applications. Secondly, the technology has become more accessible through the ability to instruct it using natural language. Moreover, there is an increasing availability of high-quality data and tools. Previously, building something with large-scale language models meant searching the web for clean datasets and essentially starting from scratch. However, nowadays, there are numerous open datasets and high-quality open-source models that we can utilize for specific use cases. Additionally, we can access cloud services that provide GPUs for training and optimizing these models for particular use cases. In summary, while the underlying technology of large-scale language models is not new, they have recently reached their peak with significant improvements in both model quality and accessibility. Therefore, their application has recently become widespread across various industries. In this task, we will analyze in detail what a large-scale language model is. A large language model is a statistical model that aims to predict words in a text. This prediction is formulated as a statistical problem. If I provide you with some words, such as the beginning of a sentence, but not its end, you could predict the missing words. This type of prediction is something that we have been doing in machine learning and statistics for a long time. There are numerous ways to fit a model to the data and predict these words. However, in recent years, we have developed methods that can achieve increasing accuracy, particularly as more data is introduced. This ability equips the model with the capability to learn useful information about the world. To give you an idea of the scale of these models, an individual can read about 700 books in their lifetime. However, a large language model is trained with trillions of data points. This volume of data is something that we, as humans, cannot handle. A simple use of these models would be to predict missing words in a sentence. For example, avocados are. The model could predict something about avocados, such as their color. It might indicate that they are likely to be green rather than blue. Even though the model learns the probabilities of words, it does not truly understand what an avocado is. However, the model can deduce that avocados are delicious and not intelligent. Taking this ability to the extreme, specific tasks can be generated, such as a song about a sunset or data classification. This knowledge is acquired from the analysis of a vast amount of data, which is why they are referred to as large-scale language models. Initially, when ChatGPT was launched, the model responded to user questions based on the prompts provided. However, thanks to the development of the additional libraries and tools like LangChain, these models have evolved and acquired additional capabilities. For instance, we have Pinecone, a large language model based on ChatGPT that utilizes additional language models and tools like LangChain. This model is trained with databases related to chemistry and can answer specific questions regarding the development of certain chemical compounds, methods of obtaining molecules with specific characteristics, and more. If a user asks how to synthesize a particular molecule, explain a specific chemical mechanism, or identify similar molecules, this model can access the knowledge base it has already learned from and utilize LangChain not only to directly respond to the user but also to reason or generate an action plan. Based on this action plan, it has access to a range of tools that allow it, for example, to search for additional information on the internet, access complex mathematical tools, use them to obtain a result, analyze that result, and generate a final response for the user. Therefore, although large language models were initially designed solely to answer user questions based on their trained knowledge, these models now possess much more advanced capabilities. They can leverage a range of tools, APIs, and additional libraries like LangChain to conduct searches, gather additional information, and generate complex processing plans. In this task, we will explore the two different types of large language models that exist and review the development process of the ChatGPT model. There are two types of large language models, a base model and an instruction-following optimized model. The base model predicts the text word based on the training data of the text. For example, if we provide it with a sentence, the base language model can complete it. Even if we ask it about the capital of France, it can add relevant words related to the original question. In short, it relies on probability to determine the word or set of words that are most likely to follow the given context. On the other hand, the optimized model is specifically trained to follow instructions. These models are designed to respond to almost any given instruction. For example, if we ask the ChatGPT model to provide 3 ideas for cookie flavors, it will generate those ideas, such as chocolate, matcha, or peanut butter, instead of simply completing the sentence. How do we obtain this second type of model that can respond and follow instructions? It requires an additional training process of the base model. To transform the base large language model into an instruction-following optimized model, we need to train it with significantly more data. Firstly, we proceed with fine-tuning. This involves providing a series of examples where the desired output follows a given instruction. This allows the model to learn how to respond in a specific way to a given instruction. Additionally, we gather human ratings on the quality of the model's results based on different criteria such as usefulness, safety, honesty, and correctness of the answers. Next, we adjust the large language model to increase the probability of generating higher rated results. This is done through reinforcement learning from human feedback. This process was precisely followed to develop the ChatGPT model. The development of the ChatGPT model involved 3 phases. In the first phase, supervised learning was utilized, where a set of prompts was provided and a human labeler responded to each prompt. Using this dataset, the existing GPT 3.5 model was fine-tuned. After completing the first phase, a reward model was created. A prompt was given, and the model generated different responses to that prompt. These responses were ranked by the human labeler, indicating the best and worst ones. This process resulted in a reward model capable of evaluating the quality of responses. Finally, with the fine-tuned GPT 3.5 model and the reward model in place, the existing model was further improved. Using a new prompt, the optimized model was initialized to generate a response. The reward model was applied to evaluate and classify this response. Based on that evaluation, the model was asked to generate a different response for the same prompt, and the reward model was used again to assess whether the new response was an improvement over the previous one. This iterative process led to the enhancement of the optimized GPT 3.5 model. This process describes the development of the ChatGPT model, which consists of a base large language model GPT 3.5 and an instruction following optimized model generated through the aforementioned process.